Hello and welcome back. So now we want to talk about our first type of energy source, which is going to be hydrocarbons. So this is going to include gasoline and natural gas and other things that are made of hydrogen and carbon. So hydrocarbons. So all of these things are going to be long strings of hydrogens and carbons put together. So, if you recall, when we talked about minerals, we talked about the silica tetrahedron, and that was when you would have a silicon atom, and a silicon atom is in column 4, which means it's got 4 valence electrons, which means it can hook onto 4 other things. And then what we found was that the silica tetrahedron would hook onto oxygens, and then you could have isolated silica tetrahedrons, and that would make one kind of mineral, or you could put them into a chain, or you could take the chains and put them into a sheet, or you could make three-dimensional structures out of them. Well, this is going to be very similar, but instead of silicon, this is going to be carbon. So carbon is also in column number 4, which means it can hook onto 4 different things. So silicon is going to make up the backbone of the silicate minerals, which makes up like 90% of the rocks on the earth. Whereas carbon is going to make the backbone of these hydrocarbons. And then later we're going to find out that it also makes up the backbones of organic molecules. So we'll get to that later in the course. But the first one down there at the bottom is going to be methane. And methane is going to consist of 1 carbon atom in the middle, and then it's going to be attached to 4 hydrogens. So this was silicon attached to oxygens. This is carbon attached to hydrogens. And this is the simplest type of hydrocarbon, and it's going to be a gas. So that when you have just a few of these things that are stuck together, it's going to be a gas, but the more that you put on, the more they start to interact with each other, and then it becomes a liquid. And once you get past a certain point, it is going to actually turn into a solid. So this picture here shows all the different kinds of hydrocarbons that you can have and how they can hook together. So when you've got a hydrocarbon and you start pulling off those hydrogens, that's going to release energy. And so that is the process by which all of these organic materials are going to produce their energy. Okay, so the next thing is, how do hydrocarbons form? So now this occurred millions of years ago. Well, actually, the same process is occurring today, but it does take millions of years to start with the organic material and then compress it and heat it up enough that it becomes a hydrocarbon. So we're going to start with microscopic organisms that live in the ocean, and they are going to be made of carbon. And then when they die, they are going to accumulate on the ocean floor. Now, if they're not covered up, then what can happen is they decompose. And so that's no good. So what we need to do is have a burial of that organic material, and then as it gets more and more stuff pushing down on top of it, it's going to start to heat up, and it's going to start to turn into just the hydrogens and the carbons. So all of the other stuff goes away, and you're left with just the hydrogen and the carbons that have been squished together, and then that's going to be oil and natural gas. Okay, then what can happen though is it will start to float to the surface because it's going to be less dense than the rocks that it's in. So on the picture that is off to the right, it shows the temperatures and the pressures that are necessary in order to make some of these hydrocarbons. Okay, then the next thing is, so once we have made the hydrocarbons, what happens to them? So the hydrocarbons are going to be manufactured in what's referred to as a source rock. Okay, then it's going to start to go up to the surface because it's going to be less dense than the rocks that it formed in, and it can flow. So as it's going to get into a crack or something and then start to flow up to the surface, and it's going to get into another rock going to be called the reservoir rock. So that's where it's going to collect, and if there was no seal rock on top of it, then what would happen is that it would just continue to climb until it would get to the surface, and then it would start to decompose. So that would be no good. So what we need to do is have a way of trapping the oil and natural gas under the ground, and that's what the seal rock is. So the seal rock is going to be made of impermeable rock that doesn't allow the oil or the gas to go through it. And so the oil and natural gas is going to pond underneath it, and then all we've got to do is drill down to it in order to recover those materials. So how are conventional hydrocarbons recovered? So this is your traditional oil wells that you may have seen from the 1930s, 40s, 50s, 60s, in which they are going to drill down to it. They have to put a casing in there in order to keep the oil from mixing with the surrounding rocks and the water table. And then they're also going to use something called mud that they are going to put down the well, and then that's going to hold the oil there until they're ready to start to bring it back up again. So here is a video that you can watch. You can see it's in black and white, but it does a very good job of explaining where does oil come from and then what's the process used to extract it from the ground. So where are conventional hydrocarbons found in the world? So here is a picture that shows the location of major oil deposits and gas deposits, and then it also shows which of these various places has the most. Okay, we're going to take a break, and when we come back, we are going to talk about unconventional hydrocarbons.